So in the last video, we did a Riemann sum with 4 subintervals, and we did a left Riemann sum and got 340,476, and we did a right Riemann sum and got 365,337. So this time I said I want to get a better estimate. I want to get something closer to the actual truth, so I'm going to increase the number of subintervals, and I'm going to use n equals 6 this time. Now, we counted last time, there are 13 pieces of data, so if I want to try to do a total of 6 subintervals, I'm going to try to do every 2 years or so. So here's what I'm going to do. I'm going to start off at 2003, and I'm going to go to 2005. So that's really 2 full years right there. And then I'm going to use 2005 and go to 2007, go from 2007 to 2009, 2009 to 2011, 2011 to 2013, 2013 to 2015. So that's going to give me a total of 6 subintervals. So I'm going to write all these years down on my timeline here. Put 2008, silly Mr. Aaron. All right, so 2011, 2013, and 2015. Now, I'm going to do one additional one this time. Instead of just doing a left sum and a right sum, I'm going to also do a midpoint sum. So, you'll see how I do that in just a second. I'm going to start off again with the left one. So, between 2003 and 2005, I'm going to choose the left number, which is the 2003. So, I'm going to go up to 6,936, and that's going to be my first. Again, not worried so much about the exact height as far as drawing it in the picture. This is just kind of giving me a good idea of what I'm doing. So, 2005, 2007, I'm using the left number, which is the 2005. It jumps all the way up to 54,037. So that's a really big number. We went really high up, 54,037. Now, 2007, we went down just a little bit to 45,834. 2009, we really dropped. We went down almost by half again, and we are at 25,461. 2011 went down, kept going. I know my graph isn't looking perfect here because I almost have 6,000 looking like 17,000. It's kind of crazy. 2013, still right about 17,849. 17,849. Not a big difference between those 2 years. Not a big difference at all. Now, again, let me repeat. This f of x is the height. It's what I wrote on my graph. This delta x is my width. Now, again, this is 2 years. 2003 to 2005 is 2 years. So we're going to take 2 for my number of years, for my width, and multiply it by my height, which is 6,936. Then I'm going to do it again. 2 times 54,037. Keep going. 2 times 45,834 plus 2 times 25,461. All right, calculator time. So I got all these numbers up here. So 2 times 6,936 plus 2 times 54,037 plus 2 times 45,834 plus 2 times 25,461 plus 2 times 17,017 plus 2 times 17,849. Much better estimate than some of the ones we've had before. Actually, this one's worse. 334,268. That's lower than what we had before. Even though I had more subintervals, I had a lower total. Now, the reason that is it just so happened that when I was using 2006, that was the maximum. That was the most number of cars they sold. So let me go ahead and write this down. When we did a left sum at n equals 6, we got 334,268. Now, making sure I mention this. Notice these are all actually pretty close together. They're all in the 300,000 range. So we know we're getting pretty close to what the actual answer is, but I'm going to keep going and see if we can get a better answer. All right, so I'm going to go ahead and do the right sum again, and then we'll do the midpoint last. So, right sum. I'm going to erase what I got here, and instead of using the left number for the rectangle, we're going to use the right number. So, from 2003 to 2005, the right number is 2005. So I'm going to use 2005 as that height. So 2005 is 54,037. So way up there. All right, then 2005, 2007, I'm using the number on the right, which is the 2007. Again, it didn't have a big drop. It went down from that to 45,834. This is when we really start to see the drop. So 2009 is 25,461. So almost gets cut in half. Then 2011 is 17,000. So it just keeps on dropping, keeps on dropping. 17,017. 2013, not too big of a difference there. Again, 17,849. And then 2015, being one of the lower numbers, we have 15,223. Let's see if that gives me a slightly better estimate. So I'm going to start writing everything down. Here I go. So again, my width is 2 years. So I'm going to multiply 2 times 54,037 plus 2 times 45,834 plus 2 times 25,461 plus 2 times 17,017 plus 2 times 17,849, and my last number here is 2 times 15,223. All right, trusty calculator time. Trusty calculator time. Here we go. So 2 times 54,037 plus 2 times 45,834 plus 2 times 25,461 plus 2 times 17,017 plus 2 times 17,849 plus 2 times 15,223. Let's see. Oh, we're getting closer. So this time we've got 350,842. Still pretty close. They're all right there together. We're still, like I said, in that 300,000 range. Let me move the camera over just a little bit so you can see a little bit better. So, this time we're up higher. Now, it's not always going to be that case. It's not always going to be where the left number is lower and the right number is high. It's not always going to be that case. But it does happen to be what's happening in this situation. Now, I said I was going to do one more. I'm going to do the midpoint Riemann sum. And that's going to be just a tad bit different, but it's going to be pretty easy on this one. You're going to see in just a second. So, I'm going to repeat myself. I always do. So, when I was doing this, when I wanted a left Riemann sum, I used the left number of the rectangle. When I used the right Riemann sum, I used the right number in the rectangle. So, if I want to do the midpoint sum, you probably guessed it, I'm going to use the midpoint between those two numbers. So the number that's between 2003 and 2005 is 2004. So I'm going to use 2004 as my height. So if I look at 2004, that's 47,013. That's going to be the height of that first rectangle. All right, next one. From 2005 to 2007, the midpoint between those two numbers, between 2005 and 2007, is 2006. There's that big number again. I know that this is going to be a much higher estimate because of that. So, 61,306. Between 2007 and 2009 is 2008. That's another 45,000. So this time we got a bunch of big numbers. 45,220. All right, I'm going to keep going. 2009 to 2011 is 2010. That's the middle. There's going to be 20,364 in there. 20,364. And 2011 and 2013, midpoint is 2012. That's 19,000. 19,789. And then from 2013 to 2015, the midpoint is 16,583. All right, for this last calculation, I'm going to go ahead and do the same kind of idea I had before. I'm going to multiply the width of these rectangles, which is 2, 2003 to 2005 is 2 years, and multiply it by the height, which is those numbers up there. So, I'm going to erase my other calculations just so you can see this one nice and pretty. Here I go. So, 2 times my first number, which is 47,013, plus 2 times 61,306, plus 2 times 45,220, plus 2 times 20,364, plus 2 times 19,789, plus 2 times 16,500, that doesn't even look like a 16, 16,583. All right, here I go. Calculator one last time. 2 times 47,013, plus 2 times 61,306, plus 2 times 45,220, plus 2 times 20,364, plus 2 times 19,789, plus 2 times 16,583, and we get 420,550. Wow, that is a way overestimate. But that's what happens when we get a bunch of big numbers. We will oftentimes get a higher estimate than what we had. Now, I will mention that these left-right Riemann sums that I did before were actually all underestimates. But here's another Riemann sum that I just did that's an overestimate. Now, it really just depends on, number one, the data, or number two, the function. If the function or data is different than what I have here, they could switch. Your right could be an underestimate. Your left could be an overestimate. Your midpoint might be right on the money. Who knows? It all just depends on, again, the data and the function that you're looking at. So, if you want to know the truth, it is 392,632 cars that were sold during this time. Now, let me repeat one more time. 392,632. So, while this is an overestimate, it's still a pretty good estimate. It gives me a good idea of where the data is. It's somewhere in here, in this 330 range to somewhere up there about 420,000. All right? Hope you all have a great day.